Hey guys, Professor Doney back again. Gonna do another problem for center of mass per request, and do a little differently here. What we have is sort of a seesaw balance beam kind of thing going along here. A balance is set here at this fulcrum. We call the balance point sometimes a fulcrum or pivot point, and we have 100 kilograms hanging at the end 4 meters away, a 10 kilogram hanging at 2 meters, and a 10 hanging at 6 from the other side. Now we also have the mass of the board we have to account for, and we want to find out where to put the 80 kilogram to balance this. So we're assuming that if we set this up and let it go, it would not balance. That we need to add this 80 somewhere to get this to balance right here about the pivot point or the fulcrum. So how do we go about this? Well, we're going to see in a later chapter when we look at statics and equilibrium that we can use the idea of torques, the sum of torques, to figure this out, sort of what's on the left equals right. But we're going to continue to use center of mass. So we're going to go back to our center of mass equation, which is x, which is, Simon says, try this again, x center of mass is adding up all the masses times their distance times the total over the total mass. Now we're going to have 1, 2, 3, 4, 5, so we have to include the 80. We also have the mass of the board. Where do we put the mass of the board? Well, we consider a board to be a geometric shape that is symmetrical about its center, so we're going to add that 100 kilograms of the board acting right here at 5 meters in, or basically the halfway point. We put it at the center, at its center of mass, which is the center. So at center or at center mass. Okay, we're going to go through and do this. We're going to put all the measurements going to be taken from the left side here. We're going to call that x equals 0, measure over. What else do we have to think of while we're here? We have the 10, the 100, the 10, the 100, and the 80. Now we're told where to put this. We're asked where to put this to balance, meaning that's going to be a distance x. So what we're trying to find is the x value, or the x distance for the 80 kilogram. That's what we're finding. And we're told we want it to balance, and I'm assuming right here at this fulcrum that we already have. So we're going to set the x center of mass equal to 6, because that's how far away this balance point is from the left end. So I force it and tell it to be at 6. Alright, going from the left side here, we're going to have the 10 at 0. Right, it's at the very end here. We're going to have the 100, which is the board, acting at 5, plus that 10, that 10 acting at 7, right? It's 5 plus, or 6, sorry, make that at 8. It's early, guys, sorry. 10 at 8, plus the 100 all the way at the end, that's acting at 10. And then we also have to include this 80 that we're adding in here to balance. Where is that going to be? We don't know, so we call that x. Alright, didn't fit everything on one line, but 1, 2, 3, 4, 5. 1, 2, 3, 4, and the 80 makes 5. Alright, on the bottom we have to include everybody, so that's 10 plus 100 plus another 10 plus another 100 plus the 80. Come down, that mass will equal 6. Let me change colors here just so it doesn't get, I don't know if that's any better, kind of dark. 6 will equal 0. Let's see, at the top I have a 500, I have an 80, I have 1,000, and I have an 80x. And along the bottom here it's 280, looks like a 300 there. Alright, so we have this equation. Now we can add these up together on the top. That's going to give us 6 equals 1580 plus 80x, that's over 300. To clean that up, I'm going to multiply both sides by 300. That's going to give me 1800 here equals 1500 plus 80x. Subtract 15 from both sides, I get 300 equals 80x. And that tells me that x is going to be 3.75. So if I hang that 80 here at 3.75, it's going to be balanced, and there's your answer. Hope that helps. Ran out of time. Talk to you later.